In this video, we continue our discussion of infinite series, and we look at a third example of the limit comparison test. Let's take a look at example 3. Use the limit comparison test to determine whether the following series converges or diverges. So let's get started. Let's write down our series n equals 5 to infinity of 2n squared plus 9 over n to the third minus 3n squared minus 4n. This series is a positive term series ranging from 5 to infinity. And one key thing that I want you to look at is how are we going to determine that limit comparison test is actually a good test for us to use on this type of series? Well, often when you have the polynomial divided by polynomial, that's often series that are candidates for the limit comparison test. Okay, so we need to find a series b sub n to compare to. And in the last example, if you recall, and the one before it, I kind of looked for the highest degree term in the numerator and the denominator. And so that's exactly where I'm going to look right now. I want to look at the highest degree in the numerator and the denominator. And so I'm going to let the series b sub n be the series 2n to the second over n cubed. But specifically, that can reduce down, can't it? That can reduce down to the series 2 over n. Oh, and what is that? Well, let's look. If we take out that constant multiple of 2, what are we left over with? We're left over with the harmonic series, right? 2 over n is the harmonic series. And what does the harmonic series do? It diverges. So hopefully we get a conclusion over here with this limit as I take my limit. So let's now go and let's actually take the limit of a sub n divided by b sub n. So applying the limit comparison test, I want to take a limit of a sub n, which is 2n squared plus 9, divided by n to the third minus 3n squared minus 4n, divided by b sub n, which I'm choosing to be 2 over n. And simplifying this limit down gives us 2n squared plus 9 over n to the third minus 3n squared minus 4n times the reciprocal, which is n over 2. That gives us, using algebra and the distributive property, the limit as n goes to infinity of 2n to the third plus 9n over 2n to the third minus, 6n squared minus 8n. When we take our limit as n goes to infinity and we have a polynomial on top of a polynomial, the only two terms that are going to have the effect that we're looking for is the first highest degree terms. That is, this limit is equal to the limit as n goes to infinity of the highest degree on top divided by the highest degree on the bottom. And what happens? Because of the way we set it up, because we chose the b sub n we did, as n goes to infinity, we are simply taking a limit of 1, and that's 1, which is a finite number not equal to 0, which means that the limit comparison test conclusion states that whatever b sub n does, a sub n also does, and therefore, since b sub n diverges, a sub n also diverges. So this series diverges. Let me write that down in a summary. So we let b sub n be the series 2 over n. This diverges because it is a multiple of the harmonic series. Since the limit as n goes to infinity of the nth term, 2n squared plus 9 over n cubed minus 3n squared minus 4n divided by 2 over n equals 1, which is finite, not equal to 0, the limit comparison test tells us that our original series, n equals 5 to infinity, of 2n squared plus 9 over n cubed minus 3n squared minus 4n, must do the same thing as the series we compared to, and therefore it must diverge. I like the limit comparison test. It's a quick test for positive term series, particularly those that are versions of polynomial divided by polynomial or a similar rational function where you have n to some power over top of n to some power.